Hi everyone, I'm Navneet and I'm one of the educator in the EduTech. Before we start with our video today, I want you all to just subscribe to my channel by clicking on the bell icon and like my videos. I'm here just to talk to you all about the computer organization. Today in this video we will learn about the computer organization. Basically here we are today in this video we will be learning about the main topic called as input output organization. And in this input output organization the topics which we will cover here is accessing IO devices, interrupt hardware, DMA, buses, interface circuit. This is all we will be learning today. Each and everything we will learn in detail from now. Learning going forward, we will be learning about the access mechanism, accessing an IO device. Okay, accessing an IO device. Okay. So this accessing of IO device means here these are the computer parts. Okay, these belong to your computer parts. Computer parts, and these are your IO devices. Okay, so basically what we are doing here is we are connecting different types of IO devices. It may be your keyboard, it may be your mouse, or it may be your printer. These are all your input-output devices which we are connecting to your main computer. How can this computer parts access these IO devices? Means it is having a bus. Through buses you can access any device. So one single bus. This is actually a bus. Okay. This is a bus. Even this is also a bus. Okay. So through one single bus structure is more than enough to access any number of IO devices. Okay. And in this bus we have three types of lines are there. Okay, inside a bus, this is inside one big bus structure. So this bus can be looked up like this. So inside a bus we are having three different structures. One line called as your address line, and the second line called as your data line, and the third line called as your control line. So what does this address line, data line, and control line do? All the processor, if a process want to access any IO devices, before moving to that, we know that every IO devices should have what? Should have a unique address. Okay, it will have a unique address. This is your first point. It says each and every IO device. Then only you can access this particular device. Or otherwise, if every device have same addresses, you can't access this particular device only from all the other devices. So in order to access any devices, that particular device should have a unique identification address. Okay, that here we are taking it as an address. Same way as how you have your USNs or your roll numbers, which is a unique identification for your particular one particular person. The same way each and every IO device will have a unique address. Then, so what this process will do? This process will first set up an address. It will just give an address of the particular IO device which it wants to access. So it will just send it to the address line. So address line comes in point here, where you will be placing an address to the line of whichever IO you want, or any address, or this IO device wants to write anything into memory means it will just give the address first to that particular location. That location address it will send in the address line. Then the data is what you will get, or what you want, or what you are fetching, or what you are storing is will be stored in the data line. And your control line is it will control n number of devices, because there are n number of devices. All the devices can't access the memory at the same time. All the devices can't access the processor at the same time. So this control line will show that whether the processor is free or not. If the processor is free, then it will say it is yes, and it will allow that device to talk to the processor. This processor, whatever it wants to talk to some IO devices, get a data from an IO device means first it will place, it will here in this bus it will place the address will be placed. Address of what? Address of this IO device will be placed in the address line. Once it places the address of the IO device to the address line, then this address line will search for the address and it will come and it will search this IO device. Once the IO device is searched, this IO device will place the data, whatever the process intended data what the processor is requesting to the data line, and then it will go to the processor. So processor can either read or write operations. These are the operations which a processor can do to read or write or data. So this is all about your accessing thing. So how to access? There are two ways of accessing an IO devices. Okay, this accessing can be done with two ways. Two ways. Okay, one is memory mapped IO. Other one is IO mapped IO. Accessing an IO device was done with two methods. One is a memory mapped IO, and another one is an IO mapped IO. So in memory mapped IO, we told that memory and IO devices, they should share a common address space. Only when they share a common address space, then this mapping will work. Okay, so they should share a common address space. So there is some common similarities between your IO and the memory. That is called they will share a common address space. And secondly, the data transfer instructions what comes in your memory mapped IO is actually it can be anything, any data transfer instructions you can use. For example, you can give a data in AR where a data is nothing but an instruction which you give in the keyboard. So you type anything. For example, you may give some instruction saying that you have to add R1 and R2. So that instruction is your data. Something from your keyboard, anything which you type in your keyboard is your data. That will be stored in your R0 address space. So any data transfer instructions can be used to exchange the information. For example, we have add R0, R1, R2. So R1 and R2 will get added and it will be stored in your R1. The same way it will come for the other method that is called as IO mapped IO. In IO mapped IO, what we will do here is we are having memory and IO devices. These both memory and IO devices should not share a common address space. Okay, whatever you have learned here, the opposite of that is your IO mapped IO, which says that memory and IO devices share different address spaces here. Okay, and secondly, we will say that there are special instructions. Okay, there we told any data transfer instruction was enough to exchange the information, but here to exchange anything, any data transfer you have to do means there are special instructions and they are in and out, use and in and use and out. We have instructions which we can use for in and out is S in, S out. We can set these bits to zeros and ones. We have data in, data out instructions. These are specially designed for IO mapped IO. The advantage of this IO mapped IO is having a separate address space for IO devices. Not all the IO devices will use all the address space. Only each IO device they will deal with only fewer address spaces. That is the reason we can have IO mapped IO more frequently. We can have a separate address space for IO devices. Next topic which we will be learning here is IO interface for an input device. This is an input device and we have to know the interface between these IO devices. Okay, input output devices. That is what we will be learning. So here we have three different terminologies which we will be learning. One is your address decoder, status register, and your database. You can see this diagram. In this diagram, what we have done is we have the bus, and using this bus, we have connected it to one of these interfaces, one of these interface component, that is your address decoder, control circuit, and a data status and control registers. Now we have an input device. From an input device, always remember input device can send a data only, it can't receive or write. So it is sending a data. That's why we have written only one-sided arrow bus. This is also a bus which is having one-sided arrow. So this is sending the data to the data status and control register, and it can have control signals both the end. It can also control and it can be also controlled by the processor. So that is why it is having two-headed arrows. And regarding the address, always the bus will only send the address to the decoder. Address decoder can't send any address to the address line of the bus. So always remember, you have to map. This is very important when you are writing in an exam. The diagram should be very clear. What the contents inside what you are writing, it may be a big change. Like if you have address decoder, you may have address fetcher, or you can write like that. But you have to have these boxes very clear. It should have a 3-box interface and IO device, and the arrow marks are very important in your computer organization when you write your exams. So here the address line, from the address line, whatever address you want to get it from the address line, when once that you put anything to your address line, from your address line it will come to your address decoder and it will get decoded here. After it get decoded, the address will know where you have to send. Then there will be some control statement. Using that, it will come to the control circuit. Using these control statement, it will control the IO devices. And the data from this IO devices will be just put into your data or status and your registers, your control register. This will be put your data line. Now, what is this address decoder does? It's simple, very simple. It enables a device, whatever device you have taken, that device will recognize whatever address you have seen on the address line. Any address you put on the address line here, that will be recognized by this address decoder. So it is making a device to recognize the addresses when seen on the address line. What is the status register do? It will contain the information relevant to the operations of the IO. That is the status of this IO. What operation it is taking. Like for example, there will be addition. So what is the status now? It is adding. That status information that is relevant to the operation information will be taken care of by your status register. When you come to your data register means it will just transfer your data. So it is used to hold the data, and after it's holding the data here for some time, and once it gets an address location, once it is called by a processor, it will just transfer the data to the processor. Here we have two bits. One is data in and data out. Data in means this is an input buffer which is used to get the data from the keyboard. That is called as data in. Whereas the data out is an output buffer which is used to put out or display the output on your screen, on your monitor or your printers. These are called as your IO interface for an input devices. The next part what we will be learning here is the mechanism for accessing an IO devices. What are the three mechanisms how can you access an IO device? Basically an IO device can be accessed either through your processor or a program controller, that is your PC, program controlled IO device, or it may be your interrupt IO device, or it can even have a direct memory access. These are the three ways how you can access your IO device. The first one says your program controlled IO devices. Here what happens here means every time this processor will keep on be checking the status flag. That is what it is repeatedly checking the status flag. To see what? To see that there is a synchronization between your processor and IO devices. Whether your processor is synchronized with the IO device or not means the processor sending time and the IO receiving time, or the processor receiving time and the IO sending time, whether they are same. That is what will be checked in your program controlled IO devices. So the processor will repeatedly check the status flag to get to know that whether there is a synchronization between your processor and IO devices. So what is a drawback? It's only one drawback. Every time you keep on checking the status flag to get to know the synchronization means there is lot of wastage of time. So this wastage of time in checking the status of the device, whether the device is in synchronization with the processor or not, before the actual data transfer takes place. There is no data transferring yet. So before you transfer the data, you have to repeatedly keep checking the status whether it is synchronized. Only when the synchronization occurs, there will be no data loss. Without any data loss, you can transfer the data. This you will learn in your data communication. In data communication, they will tell you all about the data losses and everything. So synchronization also comes there. Synchronization, just keep in your note that the synchronization means the bit rate at which the processor is sending or receiving should be same as the bit rate of the data sent by your IO devices, and you are received by your IO devices. So that synchronization, for to maintain that synchronization, you should every time keep on checking the status flag. So this will actually is a big drawback for program controlled IO devices. So after this we moved on to the next. After this mechanism we moved on to another mechanism. They developed another mechanism called as interrupt IO. Interrupt IO means what? It initiates an action instead of a processor. So there is an action initiated. Now I want this IO device wants memory. So it will initiate, it will give a signal, it will initiate an access. Every time the processor, instead of the processor calling the IO devices every time IO devices, instead of that the IO device only will tell that I want to send the data, or I have to receive a data, I want to fetch the data, or I have to put the data into the memory. So this will initiate an action and be instead of your processor. So that how it will do means it will send an interrupt signal. INTR means interrupt. So that is an interrupt signal. It is interrupting any process taking place. For example, you may have a process taking place. You will be sending some. You will be, for example, there may be a communication which will be going in between two of your friends. So in between you say that no, I have to tell something. I am leaving out. I am going out now. So I have to tell it very fast. So when you are telling that, that is an interrupt. You are interrupting their conversation. So there is an interrupt. That interrupt is done here. So there is a signal sent. Once the interrupt signal is there, that is you are raising your hand. One of the teacher is teaching in your class. So that when your teacher is teaching, she will be telling something important points. You can't directly just say that ma'am I did not get you that. So what will you do? You will raise your hands first and you will ask permission. Then you will do the same way. This IO device also will send an interrupt signal. Where it will send over the bus. Once when it is sending over the bus and interrupt signal, I have to interrupt this process and I have to just ask something. I want some, fetch some data or send some data. So whenever it is ready for data transfer operations, so whenever it is getting ready to send the data means then this IO device will send an interrupt signal. Then next we have another mechanism called as DMA. DMA means direct memory access. By the name it says it is directly accessing the memory, so there is no need of a process here. So here this is very special. Okay, this is only the one DMA is only the one device, IO device accessing mechanism in which you don't need processor. So it is like it acts like your processor itself, directly like a processor. Whatever your processor does, even your DMA will do. So DMA means what? It will data transfer to or from the memory. It can either transfer to the memory or from the memory. Continuously it can do this without the involvement of the processor. So the processor, whatever now it's processing some data means it can keep on doing processing that data. So that this DMA will not disturb that process. Instead of using that processor to send data, this DMA will act directly send the data to or from receive the data from the memory continuously. Okay, and the technique used for this technique, whatever DMA technique you have used here is that is used for your high-speed IO devices. Means for example, you may have some bulletin trains or something like that which goes very fast. Okay, in that cases you will not stop everywhere. Directly from the start till end it will go. But other things are like other trains which go is for every station it stops. Those trains will be your processor. So processor may be interrupted every now and then. But these now recent bullet trains which you have seen, okay, Vande Bharat trains which we say, they are from Mysore to your Chennai or from Chennai to Mysore. That's it. So that is having only two stops, Mysore and Chennai. So that is your DMA. That's like your DMA. So it is used only for high-speed devices. Whereas your processor which stops everywhere. It may be interrupt everywhere. So this is one of your three types of mechanism for accessing your IO devices. So what we learned today, to sum up with the accessing of your IO devices, that is the first topic under your input and output organization. The first topic what we learned is your accessing. Under this, the first topic which we learned is your accessing IO devices. To sum up this, what we will say is whatever we learned today in this accessing is first we basically learned about the bus structures, how the buses and how these processor and data transfer takes place and how can you access an IO devices. Among those many things, many IO devices, each IO devices will have a unique identification address, and we even got to know that IO devices through the address mechanism. Then we came across a mechanism for accessing the IO devices. Those are the three IO devices what we have learned now. So with this we complete today's one of the topic which I thought of completing it in this video, and further the next topic will be dealt in the next upcoming videos. And before I end, please do subscribe to my channel and like my videos and follow me.